1. What is the purpose of a process control block, PCB? A. To manage memory allocation. B. To store the program code. C. To keep track of process execution. D. To handle input-output operations. Your time starts now. Answer: C. To keep track of process execution. Explanation: the primary purpose of a PCB is to store information about a process's execution, such as its current state, register values, and resource usage. 2. Which of the following information is typically stored in a PCB? A. Process priority. B. Process owner's name. C. Process creation timestamp. D. All of the above. Your time starts now. Answer: D. All of the above. Explanation: a PCB contains various information about a process, including its priority, ownership, creation time, and other relevant details. 3. Which of the following operations can modify the contents of a PCB? A. Context switching. B. I/O operations. C. Process termination. D. All of the above. Your time starts now. Answer: D. All of the above. Explanation: context switching, I/O operations, and process termination can all affect the state and data within a PCB. 4. How does a PCB facilitate process scheduling? A. It contains the program code. B. It stores the process's execution history. C. It holds the process's priority and scheduling related information. D. It manages the process's memory allocation. Your time starts now. Answer: C. It holds the process's priority and scheduling related information. Explanation: the PCB contains essential information for process scheduling, such as the process's priority, scheduling state, and any other details required for the scheduling algorithm. 5. What happens to a PCB when a process is terminated? A. It is deleted from memory. B. It remains in memory but marked as inactive. C. It is moved to secondary storage. D. It is copied to the cache memory. Your time starts now. Answer: A. It is deleted from memory. Explanation: when a process is terminated, its PCB is typically removed from memory to free up resources. 6. Which component is responsible for creating and maintaining PCBs? A. Operating system. B. Central processing unit, CPU. C. File system. D. Compiler. Your time starts now. Answer: A. Operating system. Explanation: the operating system is responsible for creating, managing, and maintaining PCBs throughout the life cycle of a process. 7. What is the role of the PCB in process synchronization? A. It handles interprocess communication. B. It ensures mutual exclusion. C. It manages process priorities. D. It maintains the process's execution state. Your time starts now. Answer: D. It maintains the process's execution state. Explanation. PCBs maintain the execution state of a process, including its current progress, which is crucial for process synchronization. 8. Can a process have multiple PCBs? A. Yes, for multi-threaded processes. B. Yes, for distributed processes. C. No, each process has only one PCB. D. No, PCBs are only used for kernel-level processes. Your time starts now. Answer. A. Yes, for multi-threaded processes. Explanation. In multi-threaded processes, each thread typically has its own PCB to manage its execution state and resource usage. 9. Where is the PCB stored in memory? A. In the program counter. B. In the CPU cache. C. In the kernel stack. D. In the virtual memory. Your time starts now. Answer. C. In the kernel stack. Explanation. The PCB is typically stored in the kernel stack, which is a reserved area of memory used by the operating system to manage process-related data. 10. Which operation involves switching the PCB of one process with that of another? A. Process creation. B. Context switching. C. Process termination. D. Interrupt handling. Your time starts now. Answer. B. Context switching. Explanation. Context switching involves saving the state of the currently running process by updating its PCB and then loading the PCB of the next process to be executed. Thanks for watching. Subscribe for more videos. Don't forget to share and like the video. Best of luck.